Yep, we're welcome to these aspects inverse Laplace transform. Okay, from the previous video, we've said that Laplace, this is a symbol for Laplace, and this symbol is the same as what? As this L of f of t. Okay, you can put your domain there. Okay, so when we talk about inverse Laplace now, what is the symbol? So inverse Laplace as this L exponential of minus 1 of this function. And don't forget, this same symbol here is also the same thing as what? When you take inverse of a Laplace function, it's going to give you what? That's that function, f of t. This is another symbol for Laplace. This is another symbol for Laplace. This one and this one is also the same thing. Table 7.4. Don't forget, this one is same thing as what? This is equal to what? See here that inverse Laplace is for fraction. We use it when we have a fraction. You have a numerator and denominator, and that is when we use inverse Laplace. The first table we look at is a over this. Okay, if you take the inverse of this function, inverse 2, this is equal to a, that will be a, then 2. Inverse of n factorial all over x n plus 1 is what? Is t to power what? To power n. Another one is 1 over x minus a is equal to what? Is equal to this. Okay? This is almost the same thing between antiderivative and derivative. Okay? Integration and differentiation. Just the same way. The Laplace of this, you get this one back. Likewise, this one also, you do the Laplace of this, you get this one back. Number 4, this function over this function, this will give us what? Sine what? Sine bt. Sine bt. Then the fifth one, when you have x over s squared plus b squared, that will give us a cos bt. Okay? Then the sixth one, if you now have this, you have this, then you have this is plus and you have minus here. Okay? This will become a parabolic function of what? Of okay? Almost the same with this, just that this is positive for cos bt, and then for the parabolic, this will what? This will be minus. We can also get the parabolic of this also. That will be b over x squared minus b squared. So this will be equal to sine h bt. So that's that on this properties. Okay, let me call it some tools to use. The first one is that when you have inverse Laplace of a sum of functions, this, okay, so this will be equal to what? Inverse Laplace of each of those functions. Inverse Laplace of each of those functions. So that's that. The second one, when you have inverse Laplace of a constant with your function, this will be equal to what? This c will come outside, and that will be okay. And that will be what? That will be inverse Laplace of what? Of your functions. Then the third one is inverse Laplace of this function. Okay, when you have the expression you have here is the same as the denominator. It's going to be exponential, okay, at what you have here, and then since this and this are the same, that will be what? That will be cos bt. Cos bt. Okay, then the fourth one, inverse Laplace of b over x minus a all squared plus b squared. This will be equal to what? This will be equal to exponential, what you have here, at, and then sine what? Sine bt. The last property is when you have inverse Laplace of n factorial over x minus a, okay, exponent n plus 1. This is equal to what? Exponential, okay, at, okay, and then tn. Okay, so that's that. We are combining two things together here, exponential and t to power n. You do the Laplace of this, it will give you back at this one. So the next thing we want to look into is the applications. How can we use this table to solve our questions? How can we use it? Because it go beyond having the table in front of you. You must know how to use it. And at the same time also, you must also know your differentiation very well. So let's go in straight away and solve questions.